Hi everybody, welcome back to the Feynman technique. Today we'll be looking at these two integrals. So we're getting a 2-for-1 in this video, just like in my last two videos. We're going to be using a fairly identical process to the process I've used in the last two videos. Okay, so let's get going. So, just like in the last two videos, we're going to start with a standard result. Now, this that integral right there, the integral from 0 to infinity of 1 over x cubed plus 1, it's kind of difficult, but you can do it by breaking up x to the cubed plus 1 and then using partial fraction decomposition, completing the square, and evaluating the integrals separately. And you can get 2 square root of 3 pi over 9. We're going to start there. Again, that integral is you can evaluate that with standard integration techniques, and you can actually evaluate these with standard integration techniques also, although I wouldn't recommend it. It would be extremely time consuming. This one is time consuming enough, but like I said, we're going to start there. All right, so this is going to we're just redoing the process that we've done in the last two videos. So what I did here is I just replaced this one with an a cubed, okay, and then I factored out a 1 over a cubed to get this. And then again, just like in the last two videos, we're letting u equal x over a, and therefore dx is a du. And the motivation, but the process that I'm using should become, you should see a pattern to what I'm doing here. All I'm trying to do is create an integral that, basically matches this one just times a constant. Okay. So we have that the integral from 0 to infinity of 1 over x cubed plus a cubed dx is 1 over a squared times this integral, which we stated at the beginning of the video was equal to 2 square root of 3 pi over 9. So this integral right here is equal to 2 square root of 3 pi over 9a squared. Okay, so from there, we are going to let our a equal I to the 1/3. Now the principal value of I is e to the I pi over 2. Taking that to the 1/3 power would give us a is equal to e to the I pi over 6. And the reason I do that is so that I can plug in a right here and just get an x cubed plus I. Okay, so continuing, we plug that value in to this integral equality here, and we get this. We use Euler's formula to break up e to the negative I pi over 3 into its cosine and sine parts, and then evaluate cosine pi over 3 and sine pi over 3. And what we end up with is this. So we have that the integral from 0 to infinity of 1 over x cubed plus I is equal to this. All I did was distribute this 2 square root of 3 pi over 9 inside the parentheses right here. And then we can also see it's equal to this just by multiplying the top and the bottom by x cubed minus I. And that evaluates to this. So basically we have that this is equal to this, and then just taking the real and imaginary parts of both of those and setting them equal to each other, we have the answers to our original integrals. So the integral from 0 to infinity of 1 over x to the 6th plus 1 dx is just pi over 3. And the integral from 0 to infinity of x cubed over x to the 6th plus 1 is square root of 3 pi over 9. All right, this will be the last video where I use this technique to solve problems that can technically be solved using standard integration techniques. So they'll get more interesting from this point on. But anyway, I hope you guys enjoyed that, and we will see you next time.